Now let's talk about complement of an element in a lattice. So if you are talking about the complement of an element in a lattice, we should note that it is possible only for bounded lattices, right? So if the lattice is bounded, which means if it is having the lower bound and upper bound, then only I can talk about what will be the complement of an element. Otherwise it is not possible, right? So just see this. We shall see the definition, then I'll give you the example. Let capital A be a bounded lattice. For any element small a belongs to capital L, if there exists an element B, so try to understand this terminology. If there exists, which means there this element may or may not exist. That is the meaning of it. If there exists an element B belongs to L such that when I join both of them, we should get the upper bound of the lattice, and when I try to apply the meet operation, we should get the lower bound of the lattice. Then such an element B is called complement of A. It is also written as A complement, and we say A and B are complements of each other. So I don't know whether you understood this or not. I'll just take an example and I'll explain you, right? So let's take a bounded lattice that D18 and divides is the relation. Let's see that. 1 2 3 6 9 and let's say 18 is here. Okay, now this is a bounded lattice. So now what is the complement is, if you take an element and if you take some other element and if you try to apply the meet, right, then it should give you I'm not sure whether this is a proper example which I wanted to depict. Let me take one more example. What I wanted to show is all the properties that we may get. Okay, probably this will be a good example. 1 2 3 5 30. Okay, let us say there is a set 1 2 3 5 and 30, and the relation on this set is divides, and so it is a poset and also it is a lattice which is a bounded lattice. Okay, so now here if you observe it, if you take element 2, right, now if there exists another element in such a way that if I apply the join operation, we should get the upper bound of the lattice, and if you apply the meet operation, we should get the lower bound of the lattice. So in this example, if you observe, if I take 2 and if I take 3, if I take 2 and 3 and if I apply the join operation, I am going to get 30, isn't it? 2 and 3 are going to join at 30, and if I apply the meet operation for 2 and 3, I am going to get 1, right? So here if I take these two elements and I am getting the upper bound in the join and the lower bound in the meet. So what can I say is 2 and 3 are complements of each other, which means I can write that 2 complement equal to 3 or 3 complement equal to 2. Similarly, if you take 2 and 5, they will be complements of each other. If I take 3 and 5, they will be complements of each other. Got it? So that is how we define the complement. So just again I'll explain the definition one more time. See this: let L be a bounded lattice, which means we are talking about the elements or lattices which have the upper bound and the lower bound. It should be bounded. Then for any element A belongs to L, if there exists an element B belongs to L such that A join B is equal to upper bound and A meet B equal to lower bound, then B is called complement of A, written as A complement. A and B are called complements of each other. So in this example you can clearly see that 2 and 3 are complements, right? So what about this example? Now can you tell me what will be the complement of 2 and let's say okay, will 2 and 3 be complements of each other? If I try to apply the meet, they are not going to meet at the upper bound. See, upper bound is 18 and lower bound is 1. Now we know that when I take 2 and 3 and if I apply the join, they are going to join at 6 and meet at 1. So meet property, yes, they are meeting at the lower bound, but they are not joining at the upper bound, they are joining at 6. Therefore 2 and 3 are not complements of each other, right? So can you find out the 2 and 9? If I take 2 and if I take 9, what do you think will be the join and meet? So if I apply join, so we know that in this particular relation, in order to find the least upper bound, it is nothing but the LCM. If I take LCM of 2 and 9, it is going to be 18, and if I take the GCD of 2 and 9, it is going to be 1. Therefore I can say that 2 and 9 are complements of each other in this example. Got it? But then it is not necessary that we always get a complement. For example, if you try to take 6, there will be no complement of 6 in this example, right? The reason is, if you take 6 and 9, they are going to meet at 3, not at 1. Therefore 9 cannot be complement of 6. If you take 6 and 2, the meet is going to be 2 and join is going to be 6. Therefore 2 is not the complement. If you take 6 and 3, since both are related, the join is going to be 6 and meet is going to be 3. Therefore it is not the complement. If I take 6 and 1, since both are related, the meet is going to be 1 and join is going to be 6. Therefore it is not a complement. Now 6 and 18, the meet is going to be 18, join is going to be 18 and meet is going to be 6. So it cannot be complement. So for the element 6, there is no complement in this example. Therefore we have seen examples where there is exactly one complement for an element, or there is no complement for an element, or there may be one or more complements for an element, right? So if you are looking at the complements, so one interesting point is, you are going to look at it only for the bounded lattices. What could be the reason? Simple. We are defining the complement concept based on the upper bound and lower bound. If both of these doesn't exist, then we cannot define the complements at all. Therefore we are going to talk about complements only when the lattice is bounded. That is point number 1. And second point is, even though we are talking about bounded lattices, it does not mean that for every element we can find a complement. There may be a complement or there may not be complement at all. And even if a complement exists, it need not be unique, which means sometimes we might have more than one complements for an element. Okay, just remember all this.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177. And IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply. And statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days. and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.